Have some wheels dropped off. This is a Volvo wheel which we're going to use to measure up to machine these Ford wheels to fit a Volvo V60, and we're going to do that on the milling machine. So I've got a wheel sat on the milling table at the moment. The owner wants to keep the centres, so we're not going to machine this area, we're just going to machine down inside the back area there. Now I'm going to set this up on the mill table the opposite way up so that I can get to that part. But before we do that, I'm going to make a puck that will fit down inside that bore. As you can see at the moment, it's just sitting in this recess, but that's not where I want it. I want it to go down through the wheel. I'll explain why when I come to mount it. So we need to work out what that size is there. So what we've done is we've taken a snap gauge and we've checked it all around to make sure we've got clearance, and we now have a size that will pass through that area. So we'll measure that with a set of verniers, and it comes to 59 millimeters. So we want to machine this area of this puck because it's going to sit that way up. We want to machine this area to 59 millimeters, and it's currently 63. And get rid of the glare. It's currently 63. Yeah, so we'll do that in the lathe, and I'll come back to you then. This is my little stash of previous pucks from similar jobs. Yeah. So we've now made the puck, which fits into the wheel nicely with minimal clearance. We're going to put a piece of wood across the wheel, and we want to see a gap, a small gap underneath, so that when we turn this upside down, we're going to be resting on the wheel, not on this part here, on the puck itself. So now we'll mount the puck. Right. There's somewhere about there. Very humid today. All the machines are soaked. I know there's water on the wheel because I brought it out from outside, but even indoors All my machines are absolutely soaked. So that's firmly on there. So what we're going to do now is we're going to fit a coaxial bore gauge in this collet holder. And you see what I'm doing? I just adjust this slightly. There we are. So now we've got our puck firmly bolted to the milling table, I'm going to stick a coaxial indicator on here to zero the puck to the spindle of the milling machine. We've got to do this under power, on a slow speed. So if I can zoom in a bit for you. So now I'm going to adjust the y-axis until I get less movement of the needle, and at some point it will start to get bigger again. There. Now we're going to adjust the x-axis. That's getting bigger, so I need to go the other way. Back to the y-axis. And there we are. We're down to about maybe 0.2 of a millimetre. What we can do if we want to is switch that off now and do it by hand. So if we start with our y-axis, so from the top there, if I set that to 0 and bring it round to the bottom side, and that'll tell me how much I'm out that way, and it's 1/10 of a millimetre. So try to split the difference. To be honest, that'll be quite hard to do, especially if you go the wrong way, which I always do. There we are. Right, so now I'm going to go on the x-axis, and we should be able to just zero that in. That's perfect, that's perfect. So within 1/100th of a millimetre. I am not going to fuss any further than that. I'll switch the machine on. Put it into gear without. That's within 1/10 of a millimetre. 1/100th of a millimetre, sorry. Now we dismantle all of this. Put it safely back in its box. This machine uses a funny arrangement where it has this, I suppose, and that thread will not fit through the spindle. That's I've got a 12mm thread through the spindle, which goes into the end here. This is a Qdora boring bar, which is a Wop halter, I think it is, made under license in Japan. This is a number 3 size. I do have a number 4 and a number 5, and they get quite large, suitable for quite big jobs. But for this job we're going to use this one. Now I'll just go over how the measurements work. We have a scale here, 0 to 25, just for rough setting up, and we have an indicator here, and it reads in 1/100th of a millimetre. So each one of these, let me zoom in for you. Each one of these digits is 1/100th of a millimetre, and of course you could quite easily split them as well if you wanted to, like that. One turn of this ring is 1mm movement on the diameter, not on the radius. It's on the diameter, so it's a 0.5 mm movement, which gives you 1mm on the bore. Everything on most bore gauges I've ever used are to the diameter, so one full turn. So we can turn this 1/10 of a millimetre, sorry, 1/100th of a millimetre at a time, I believe. Yeah, 1/100th, and a full turn would be 1mm. If that's not good enough, we can pull this pin here, push this pin here, lock these two together, and then we can turn this top ring one, I think it's this one. Let me just see if I can get this locked. There we go. So I've locked this bottom pin, and this pin is released. So if we turn this one full revolution, we get 1/10 of a millimetre instead of 1mm. So it's 1/10 of the resolution, and it's accurate. They are superbly accurate. If you don't have one of these, I suggest you at least look at getting one. You often see them on the market at very eye-watering prices, but you can pick them up cheap. I think all of mine I've picked up for around £100 each, and they've all been in very good condition. You just have to bide your time. and wait till one comes up. I'm currently looking for a number 2, just to add to the collection really. That's it really. I've got a CNMG, let me zoom back out, a CNMG tip in there, which I'm going to change for a new one to do this job. I'm going to put an aluminium tip in it rather than a steel one. Aluminium as in for cutting aluminium, not made of aluminium, just in case anybody wants to pick up on that, you know, YouTube and all that. So we've got a brand new insert in. We've got our bore gauge on. We've got our puck firmly mounted. I'll just move you a bit to the table. It's firmly bolted in line. Now we're going to put the wheel on. I'm going to take these out so I don't scratch the wheel. We don't have much room to play with. But now, because we've got the puck, I don't need to centre the wheel. I can just fit it over the puck. These wheels are getting recoated, so we're not too worried if we just knock them slightly, although we'll try not to. Chip a bit of paint off or whatever, because it's all coming off anyway. I think they're going to be diamond cut, I think, and plastic coated and diamond cut, so they'll look very nice when they're finished. I'm going on to a Volvo V60 rally car. So there we are, just clamping them down with some toe clamps. I'll take a picture after. Just so the wheel doesn't move when we're cutting it. So we're on size. Let me just take the camera off here for a second. Right, so there's our toe clamps. Nothing complicated. With roughly just touching the sides there, so I'm holding the phone inside. Right, so now we can lift this. I think we need to lift the table slightly. So we know we've got 59mm bore originally, and we want a 65.1, so we want to move out 6mm. So I'm going to take out 5mm, cut it, and then measure it. So I'm going to advance this by 5 turns, which should increase my bore diameter by 5mm. 1, 2, 3, 4, 5. I'm going to just run it down and do a visual check just to make sure it looks reasonable, which it does. We'll try it on high speed. This screw here just locks it. It doesn't use an Allen key, it uses that thumb screw. So we'll just spin it up and check it doesn't vibrate too much, because once these get off a bit with a tool and everything else, this can all start vibrating. So we'll just have a quick... Oh. No, that's fine. So we'll advance the tool and take a cut. And for all the setting up, that's all the machining that's required. It's nearly always the setting up that takes the time. .5, so we want 0.6. Point 1, point 2, point 3. I'm just going to try that. All greasy and slippery. 64.9. So we want another 0.2. Right, 1.2. And that should be our target figure. I appreciate my arms in the way, but I do have to get in there to measure this. So basically I'm just snapping the ball, tightening it up. That's quite tight. I'll do that. There we go. Measure this. We want 65.1. Oh, we're still at 65. Oh, 69. Let me do that again. 65.08. So we want 65.1. I would like to take just a tiny bit more off that, I think, in case the customer has any problems. So we're going to take another, just a smidgen, not taking much. $65.12. The target is 65.1. You just see if that'll. Oh, this is tricky. Oh, there we are, 65.1. So that'll do. So we'll leave that alone where it is, because we can take that cut in one pass, and then we should do the rest of the wheels. Quick wipe. Right. So on to the next wheel. And rinse and repeat. We've now got our bore gauge set, our boring head, sorry, set, so we're not going to worry about that. It's such a small cut, it'll do it in one pass. These are so corroded, this is pretty pointless really. Okay, tighten that down. There's my socket. Bore that out. Quick check the bore gauge. V65.1210. So we call that job done. Hopefully I said something interesting along there, and you got a bit of a view of how that's done, or how it's done here anyway. And for that, I thank you for watching. Until next time. I just thought I would end with it there, just giving a bit of an overview on the mini machine. I've turned the lights out now, so it's a bit darker. And that's it. Thank you.